Consider the function f of x, where f of x is equal to 2 to the x if x is less than 2, and it's equal to ax squared plus bx minus 2 if 2 is less than or equal to x or less than 8. And finally, it's equal to x plus 4a minus 2b if x is greater than or equal to 8. First thing we want to do here is find values of a and b that make f continuous everywhere. So in order for this to be continuous everywhere, we want to have the limit at these endpoints to be equal. So notice 2 is going to be one of the places, and then 8. Everywhere else is going to be continuous, since 2 to the x is a exponential function that's continuous, and then this one is a quadratic, and this is linear. So those are going to be continuous, except we just have to look at the endpoints here. So let's look first at x approaching 2. So you want to look at the left-hand limit and the right-hand limit to be equal. So if we're looking at the left-hand limit, we're approaching 2 from the left, so that's x being less than 2, which is 2 to the x. And that's just going to be 4. And you want this to be equal to the limit as x approaches 2 from the right. So that's going to be this one, x being greater than or equal to 2. That's ax squared plus bx minus 2. And for this one, you could just plug in 2 here and get 4a plus 2b minus 2. So what you have to do is set these two equal to each other. So you'll set 4 equal to 4a plus 2b minus 2. Add 2 to both sides. We get 4a plus 2b is equal to 6. Similarly, we have to look at x approaching 8 from both directions. So let's look at x approaching 8 from the left. So that's going to be x less than 8, which is this quadratic. And you want this equal to the right-hand limit, which is from the right-hand side, that's x plus 4a minus 2b. Now if we solve these, first the left-hand limit, you just plug in 8, you get 64a plus 8b minus 2. And this limit will just be 8 plus 4a minus 2b. Now we could just bring everything on one side. So we'll subtract the a, so 64 minus 4 is 60a. 8b plus 2b is 10b. And then we'll just add 2 to both sides to get 10. So this is going to be the second equation. And here I can just divide everything by 10 to simplify it and get 6a plus b is equal to 1. And then the other equation, I'm just going to divide by 2 to get 2a plus b equals 3. If I subtract these two, I get 4a equals negative 2. That means a is negative 1/2. Plug it in. I'll just plug it into the second equation. It's 2 times negative 1/2 plus b is 3. 2 times negative 1/2 is negative 1. Add that over. You get b is 4. So these values for a and b is going to make this function continuous everywhere. Now, we want to find values of a and b that make f continuous everywhere except 2. So we don't want the left-hand limit and the right-hand limit to be equal for x approaching 2 from the left and the right. So remember, what this really comes down to is you don't want this to be equal now. You don't want 4a plus 2b to be equal to 6, but you want 2a plus b to equal 3. I said that wrong. You don't want 2a plus b to equal 3, but you want 6a plus b to equal 1. Because this was the limit as x approaches 2. That's where we got the equality from. And then the bottom one is the limit as x approaches 8. Okay. So since you don't want it to be continuous at x equals 2, you want the limits to not be equal. So all you have to do is find something that works for the second equation that doesn't work for the first. And I'm just going to keep it simple. If I let a equals 0, b equal 1, that satisfies the second equation, but it doesn't satisfy the first because you have 2 times 0 is 0 plus 1. So basically you have 1, and that does not equal 3. So this works. Now the third part would be find values of a and b that make f continuous everywhere except 8. Now for that, you want to have 8. You want to have the first equality true, so 2a plus b equals 3, since you want it to be continuous at x equals 2, but you don't want it to be continuous at x equals 8, so we're going to say that the second equality does not hold. So now you want to find what works here, so just keep it simple. If we let a equal 0, that means b is 3. That satisfies the first equation, but it doesn't satisfy the second, so because you would have 3 in the bottom, and that does not equal 1. Okay. So that would be our answer.